Okay, so I'm going to put a triangle. So I'm going to put 1 dot at 2, 4. Another dot at 2, 1. And a further dot at 5, 1. Okay, I'm going to join up that triangle. Oops. Okay. Now I'm going to put another triangle. Let's go for 1 minus 1. 1 minus 2. And 2 minus 2. So it's a smaller triangle. Okay, so try and have those two triangles. I'm going to call this one A. The smaller one is A. And the larger one I'm going to call A dash. Okay, so I'll give you a second just to draw those in. Okay, so the question here could be as simple as describe this transformation. So hopefully you've recognized that the object, so the original, is smaller than the image. Okay. So can you tell me how much bigger the image is? Anyone? I think it's 5 times bigger, perhaps. What can we compare? Twice as big, says Ethan. 3 times as big, says Lewis. You changes his answer now to 3, and Lauren changes to 3. Yeah, so we can compare the lengths of a couple of sides. So this side is of length 1 box, whereas this side is of length 1, 2, 3 boxes. So it's 3 times bigger. Same for this one. This was length 1, and this is length 3. And if you measure this side would be 3 times longer as well. So that is called scale factor. So the first thing, so I'm going to write the answer down here. First thing is, it's an enlargement. That's the type of transformation it is. It's not a reflection. It's not a translation. It is an enlargement. And I'm going to say of scale factor, which is just what we discussed, how much bigger? Scale factor 3, because it's 3 times bigger. But there's one more thing that we need to do to describe it. There's one more thing, and that is called the center of the enlargement. and it's a point, but I haven't found it yet. So there's three things to describe it. First, it's an enlargement, so it's got bigger. Then 3 times bigger for scale factor. But we need to find the center of enlargement. And this requires some construction lines to find the center of the enlargement. All right, so it's going to be somewhere on this diagram. Anyone want to have a guess where the point might be? That would be the center. I know this is a new concept for you, so any guess is reasonable. It's going to be somewhere on this diagram. Where would the center be? 5, I guess you point in the middle, so maybe you think in the middle of this shape, or 5, 2, so here. Okay. 3, 2 in the middle of the shape. That's a good guess, but it's not 3, 2. Louis thinks it's 1 and minus 1.5. So here. Oh, that's not bad. So it's the center from here. That's not a bad guess either. It's actually somewhere down here. Let's look at how to find it. So you're definitely going to need your ruler for this. So get out your ruler. 1 minus 1.5, 1 minus 2. No one's got it yet. Okay, so get out your ruler. And what we're going to do is we're going to join the corners of the shape, the vertices. Okay, so I'm going to look at this corner, and his buddy is down here at this corner. These two are buddies. So I'm going to join those two with my construction line. Nice dotted line, joining those two. And I'm just going to continue that construction line as far as my diagram goes. So I've just drawn it all the way down. Oh, Ethan thinks 0 minus 4. That's a good guess, Ethan. That is a good guess. All right, so that's one construction line done. There's 3 points on this. So I'm going to draw the second one. This dot and this dot. So the bottom right, where the right angle corner is, and the right angle. I'm going to just do those lines, dotted line. Just keep that dotted line going. Very good. Okay. I have one more to do. Okay. So, do we see what's happening here? The top left corner with the top left corner, it's going to be, you see, they're going to cross at a point. Hopefully yours cross at a point as well. Oh, and off this one goes. They all meet. Yeah, it is where they all cross. It's down here. So on my diagram, I'm just going to say that is the center. It's called the center of the enlargement. Now, whatever point is on your diagram you use. So on mine, it's about, it's a half and minus 3. So it's a half on the x-axis. So I'm going to just use fractional half. I can use 0.5 either. So I'll call it 0.5 on this one, but I can use either. And it's minus 3 on the y, so that's just minus 3. And that is the final bit of information to show if they ask you to describe an enlargement. I'll give you a second just to tidy up your diagram. So 3 bits of information. It's called an enlargement. You need the scale factor. So the scale factor is how much bigger or smaller. So it could be smaller. Oh, you got the same as me. Nice. Okay. So your diagram hopefully will look like mine. Yeah, it's going to be slightly different because you may not have drawn it in the exact same place as me. Okay. So that is when they give you the enlargement and you have to work backwards to say what the transformation was. Now we're going to do one where I give you all of this information and we have to draw it. That's going to be the next one. So once again, it's going to be another Cartesian plane. So yeah, bear with me. 2 planes every day. So you're going to have loads of these Cartesian planes in your book. Let's go with the same size as this one. Okay, so I'm going to switch now and go draw another Cartesian plane. So I'm just going to turn off my mic and you guys can copy what I'm doing. All right, so hopefully you guys have that down. Let's look at the question. I'm going to do 2 questions, so I'm just going to write the 2 questions down here. Yeah, we're going to do both these questions in the same plane. Now, I haven't drawn the shape yet, so yeah, we're going to see that in a second. Back to the center of that one. I want to see where the first one is drawn so I don't overdo it. Okay, so I'll come back and put it in the center. We're just doing the starting question 1. Shape B is going to be, well, we're going to stick with a triangle. So my points is going to be 1, 3, 1, 1, and let's go with 2, 1 here. This is shape B. Okay. All right. So hopefully you have drawn shape B on your diagram. So we're going to do this question 1. So here is shape B. So we're going to enlarge it. So it's either going to get bigger or smaller with the scale factor of 2. So that means twice as big. Now you may notice in the other question I have scale factor of 1/2. That means half the size. That one's going to be smaller. This one's going to be bigger. They're both called enlargements. The center of this is 5, 4. So if we go back to the previous question, that's the center. There was our object and our image is way off here somewhere. Okay, so let's put in this dot for the center on our new diagram. So the center is 5, 4 for this one. 5, 4. So let's put in 5, 4. 5 on X coordinate. So it's over here. Might have done that a little bit far away, but let's see what it looks like anyway. Okay, so 5, 4. So how do we draw this thing that's twice as big? Anyone have an idea what quadrant the enlargement, the image will be in? B dash, what quadrant it's looking like it might be in? Anyone have a clue? Quadrant 2. So remember, this is quadrant 1, 2, 3, 4. Luke thinks 2 or 3. Lauren thinks 3. Bianca thinks 1 or 3. A lot of people thinking 3. Yeah. If we look back to our previous one, this one, it started here, and then the image is up here. So this one, if it starts here, the object is there. I'm predicting the image is going to be perhaps down here somewhere. Yeah. All right. This time we need to start with the construction lines. So I'm going to pick. Let's just do this. Let's just do this dot. So this is my vertex. I want to draw its image. Now, this is why you definitely need a ruler for this unit. We need to measure the distance. What is the distance to here? So 0 to, I think that's around, on my diagram, 4.3 centimeters. So if the scale factor is twice as big, then this distance needs to be twice as far. So if I have 4.3, I can do a little calculation. 4.3 plus 4.3 is 8.6. So that's a little bit of rough work on the side here. So I need to go 8.6 away, twice as far with my dot. So 8.6 is going to be around here. And I'm going to put in that dot. Okay, let's just see. Let's move this dot next. Okay, so once again, your distance may be different. Mine probably will be different because I didn't use the squares from your book. Perhaps you use squares from your books. So that's going to be different. So I'm going to measure now. I'm going to do this dot. I'm going to measure the distance. 5.2 on mine. So 5.2. Let's do 5.2 plus 5.2. That's 10.4, I think. Double the distance because it's scale factor of 2. So I'm going to join my dots. So that's 5.2, but I'm going to go 10.4 now. I'm going to double that distance. 10.4. Okay, that's 10.4. All right. And let's do the last one. So that means I have to join this dot, and then a new point twice as far away. So I'm going to try and do it as much as I can on screen. My distance I'm measuring, that's 4.2. So 4.2 plus another 4.2, twice as far, is 8.4. Okay, let's make sure I get that right. Dot, dot, dot. Here's doesn't make any sense. Well, we'll see. Maybe it will. So I'm just going to go to 8 point. Keep that dotted line going. So construction line should be dotted. And it's around here. Okay. So they are my 3 points. All right. Let's join them, see what it looks like. There we go. 1. There we go. 2. There we go. 3. Look at that. Hopefully yours is looking a bit like that, and that's B dash. That is its image. Let's look. On my one, this is 1 box across. On my image, this is 2 boxes across. Twice as big. In this one, it's 2 boxes up. This one is 1, 2, 3, 4 up. We can see that it's twice as big. How did we do it? We just doubled the distance from the center. So here is our center. All right. So that's the first one done. Now I'm going to do the second one. The center of the enlargement, I'm trying to make it so it's not going to be too messy. I'm going to put it, let's use this quadrant. So I'm going to put the center down at 5 minus 5. Okay, so the second question. So I'll let you just polish off the first question, and then you can attempt the second question if you want. But I'm going to do it in a second. So all this should be in your notes. Part of geometry, can I put the paper down this way? Yeah, sorry. Part of geometry is the skill of being able to draw nice, neat diagrams, having good construction lines with these dots, and being able to draw coordinate diagrams, plot points. Okay, so I'm going to do this second one. So I'm going to enlarge shape B again, this time second question. I'm going to do a center of 5 minus 5. So that center's down here. 5 on X. So hopefully it's in the corner of your diagram as well, down here. So this is question 1 center, and this is going to be question 2's center. Yeah, you definitely need a proper ruler for this unit. I'm going to do it in a different... Oh, it doesn't have numbers? Well, that's not very good. It's failing the test of being a ruler. All right. So I'm going to do it in a different color. I'll do it in pen. Hopefully I don't make any mistakes. I'm going to do... Well, I'm going to look at this corner first. All right. So this corner is... Oh, it's 6 point... On mine, it's about 6.8 centimeters away on my ruler, that corner. Okay, 6.8 centimeters away. Now, 6.8, well, I'm not going to double that. I'm actually going to half it, because it's a scale factor of a half. So this one, I doubled it. I just added itself or multiplied by 2. This one, I'm going to half it, so I can divide by 2. If you want, you can do that on your calculator. Perhaps some people can do it in your head. What is a half of 6.8? I presume you got your decimal point there, Ethan. Half of 6.8 is 3.4. Yes, 3.4. I think you did it twice or something. Okay, so I'm gonna, or you can just, maybe if you didn't have your scale on your ruler, Charlie, you could have done just estimate half the distance, but I'm gonna go 3.4 here, and that's the first dot. There. Okay. So I did 3.4, so if I want to do that again, I can measure it either way. If I want to measure it this way, it should be at 3.4 as well. What is the question? Enlarge the shape with a scale factor of a half from center 5 minus 5. So here's our center 5 minus 5. This time we're halving, so I divide the distance by 2. The last time I was doubling the distance. This time, because it was twice as big, this is half as big. So I'm halving. All right, let's do another point. Let's do this point here. Okay, so once again, measure the distance. Let's keep it in centimeters. I'll measure it the other way this time. Just it is, on my diagram, 7.2. So a little bit of, I'm going to just draw the dotted line. 7.2. So my little rough work here is good for these calculations. 7.2 divided by 2, half the distance. Who's going to help me out here? Thank you, Charlie. 3.6 centimeters away. So that's 3.6 centimeters. The other one was 3.4. I didn't write it in. Okay, so 3.6 centimeters away is around about here on mine. Okay. Okay, 3.6. I'm not entirely convinced this is going to work, but let's see. Let's see. Will it? I have one more to do. Let's do my distances again. You can measure it from either side. Let's do this one again. This top point up here, I'm doing the top one. That's almost exactly 9 centimeters on mine. Dotted line all the way up to it. 9 centimeters divided by 2. I know. I think that's 4.5. Yes, thanks, Charlie. 4.5. All right. Let's try and put in 4.5 on my diagram. Where is 4.5? It's here. All right. That's my dot. So I have 3 dots. Let's join them. The shape will still be orientated the same way. But it'll just be smaller. Let's see. Look at that. Smaller. How much smaller? Half the size. If you notice here, it's a little bit in between points on this one. It didn't work out as nicely, but we can see that this on my diagram is 1 box high. And this original was 2 box high. So half of 2 is 1. Awesome. So this is, I'm going to call that, I'm just going to put an arrow to it, B with 2 dashes. And that's the answer to this is B with 1 dash, and the answer to this is, I'm going to just call it B with 2 dashes. Okay. Charlie thinks Ethan had a bit of an issue. Yeah, yours would be pretty small because your squares in the maths book are smaller than my squares. So yours is probably going to be, if you only used 1 box for each of these, yours is going to be tiny. Yeah, it's going to be tiny. But that's okay. If you use 2 boxes, which would be a centimeter, it might be a little bit clearer. Yours got flipped around, Lara. Ooh, you've obviously made a mistake on one of the points. So if your diagram's off, that's okay. If you understand what was happening, that's way more important. So to recap, to draw an enlargement of scale factor 2, it's going to be twice as far from the center, so we double the distance. If it was scale factor 3, it'd be 3 times as far, triple the distance. If it's scale factor half, it is half the distance. Okay, and they're the main ones. Usually do 2 or 3 or a half. They're the main 3. That otherwise, what happens is if you get 4 or 5 times the size, the actual original is too big. It's off any screen or diagram you'd ever do. So usually just do 2 or 3 or a half. All right. So hopefully that in your notes. Let me just switch cameras and I'll just go through the one task that you have today, and that's a MyMaths task again. Now I haven't checked your MyMaths tasks. Yes, I presume you have them all done from yesterday. If you didn't do them, I'll be sending emails and stuff home on Thursday. If you don't have them done before Thursday, do make sure you have all your tasks cleared for Thursday. There's a new one today. So I'm just going to switch cameras and bear with me. Okay, so I'm on this camera now, so hopefully you can see me. Just going to present and show you, just run through MyMaths. All right, so this is your MyMaths homework. It's quite short, similar to yesterday's work. For each of these two, you have to give the center of the enlargement. So although you can't do it on, you can redraw this if you want on paper. You can maybe get your ruler up onto your screen and notice, join this point, okay, that's 1 construction line, 2 construction lines this way, and 3 construction lines. So it's going to be somewhere around here. How much bigger is it? Well, you can count the sides here, count the sides, and see where that's scale factor. So scale factor, if you think it's 5 times bigger, write 5. If you think it's 20 times bigger, write 20. It's neither of those. I hope you can figure out. So this is very similar to the first example I did in the notes. Same with this. The second example here, well, this time they give you a center, and you need to draw scale factor of 2, so twice as big, so twice the distance away. Here's A, and A dash is going to be twice the distance away. So you're going to have to estimate here on this diagram. I reckon it's around here. So you put in these, drag them into shape. Same for this, half the distance away. So E dash is going to be halfway from this point to E. So it's going to be somewhere here.